Imagine stumbling upon a secret ocean lurking beneath the frozen exterior of a moon that eerily resembles the Death Star from Star Wars. That's the exhilarating revelation scientists are piecing together about Saturn's moon Mimas, and it could rewrite our understanding of icy worlds in our solar system. The evidence for a freshly formed ocean on Saturn's moon Mimas is growing stronger by the day. By meticulously mapping the depth of the moon's icy outer layer, researchers aren't just estimating how long any hidden ocean might have existed, they're also pinpointing the thinnest sections of that crust, ideal targets for upcoming spacecraft to confirm the ocean's presence. Meanwhile, a closer look at Mimas's most prominent crater is narrowing down the timeline for when this potential ocean could have emerged. When we observe Mimas, it doesn't display the typical signs we'd expect from a moon with an underground ocean, explained Alyssa Roden, a planetary scientist at the Southwest Research Institute, SWRI, in Boulder, Colorado. During a recent presentation at the joint Europlanet Science Congress Division for Planetary Sciences meeting. For beginners, think of it like this. Ocean worlds usually show surface cracks and fissures because their interiors expand and contract as ice turns to water. Much like how a balloon stretches when you blow air into it. Take Saturn's moon Enceladus or Jupiter's Europa, for example. Both are believed to have subsurface oceans, and their surfaces are crisscrossed with networks of fractures and valleys, evidence of that internal churning. But Mimas, Saturn's tiniest major moon, has a remarkably smooth outer shell with hardly any visible breaks. Its craters appear permanent, almost as if they're etched into solid rock rather than pliable ice. And this is the part most people miss. Despite that unassuming exterior, new findings are turning heads. Just last year, scientists revealed that data from NASA's Cassini spacecraft strongly supported the idea of a relatively young ocean on Mimas. This concept has been brewing for over a decade, fueled by a steady stream of Cassini observations beamed back to Earth. Early data had already suggested a youthful ocean, though experts were initially doubtful. Now, with more precise measurements, the case for an ocean buried 12 to 19 miles, 20 to 30 kilometers deep under solid ice is becoming compelling. Roden and her team adapted models originally developed for Europa's icy shell to analyze Mimas's crust thickness and heat distribution. Their findings showed that once melting kicked in on Mimas, it happened rapidly, like a snowball rolling downhill, gathering speed as it goes. But here's where it gets controversial. Is this ocean truly newborn? Or could there be alternative explanations for the moon's features that don't involve liquid water at all? Some skeptics argue that the data might be misinterpreted, sparking debates in the scientific community about whether we're jumping to conclusions. To grasp this, consider how orbiting works. As a moon circles a planet, gravity creates a tug of war. On Earth, this causes our tides. The moon pulls on our oceans, making them rise and fall. But the planet also pulls back on the moon's surface, even if it's solid. In Saturn's realm, something seems to have nudged Mimas into a more elongated or eccentric orbit. Not a perfect circle, but an oval shape. This change amplifies Saturn's gravitational pull on Mimas's icy body, generating friction that heats. Roden's group simulated various orbital shifts to match Mimas's current state. They discovered that a significant change would have caused widespread melting, erasing craters and surface details entirely. Their calculations indicate this orbital tweak occurred just 10 to 15 million years ago, a mere blink in cosmic time, aligning with prior guesses about the ocean's youth. The researchers also modeled heat movement within the moon to explore how future missions might spot the subsurface ocean. Their simulations reveal that heat flow through the ice, leading to melting and crust thinning, isn't always straightforward. Still, a dedicated orbiter could potentially measure surface heat to detect the hidden water below. It would be challenging, but definitely feasible, Rodin noted, offering hope for exciting discoveries ahead. Now, let's dive into the Death Star heart of Mimas. This moon earned its nickname from its striking resemblance to the villainous space station in Star Wars, thanks to a massive crater dominating its surface. Herschel crater spans 80 miles, 130 kilometers, over a third of the moon's diameter, and it's central to the ocean debate. Crater shapes reveal a lot about the material they're formed in. The impact not only scatters debris for study, but also shows how rigid the ground was at the time. Simulations of Herschel's creation suggest the ice beneath wasn't fully solid when the crater formed. By testing models of Mimas with no ocean versus one with a thin, icy lid over water, scientists determined Herschel probably appeared right as melting began, when the ice was soft but not yet liquid. Mimas has to be teetering on the edge, said planetary scientist Adine Denton, also from Soirée, in an interview with Space.com. It can linger there for millions of years, but it must be close to tipping. Denton shared her findings at the EPSC meeting, and the study, co-authored by Rodin, was published in Earth and Planetary Science Letters. For those new to this, think of it as balancing a pencil on its tip. It stays upright for a while, but could fall at any moment, just like Mimas's ice on the verge of change. At Herschel's core is a towering central peak, typical of large craters, formed when a huge object collided with Mimas. In earlier research, Denton showed that hitting solid ice would produce a crater without such a peak. But if an ocean lay underneath, the impact would splash water everywhere, preventing the peak's formation because liquid can't support rigid structures. Water simply can't build something like that, Denton explained. Herschel most likely took shape as the ocean started to form, during a phase when the ice was warm yet still solid. Denton's work expands the possible time frame for the crater's creation from about 1 million years to up to 10 million. Still brief geologically, but a significant improvement. It's a big leap in scale, she said at EPSC, combining Denton's crater analysis with Rodin's thermal studies and other investigations of Mimas's surface and core. Researchers are crafting a clearer story of this enigmatic moon. All these pieces are coming together to portray Mimas as a youthful ocean world, Denton remarked. But here's the real controversy. If Mimas has a young ocean, what does that mean for the potential of life? Could microbial organisms thrive in its depths, similar to debates about Europa or Enceladus? Or is this just wishful thinking with no evidence yet? And this is the part most people miss. Exploring Mimas could challenge our ideas about where life might exist beyond Earth, but it also raises ethical questions about contaminating pristine worlds with our probes. What do you think? Should we prioritize missions to Mimas to search for this ocean, or focus on other moons? Do you believe this discovery could hint at extraterrestrial life, or is it just another icy puzzle? Share your opinions, agreements, or disagreements in the comments below. We'd love to hear from you. Join our space forums to continue the conversation on the latest missions, stargazing events, and more. And if you have a news tip, correction, or comment, reach out to us at community@space.com. Nola Taylor Tillman is a contributing writer for Space.com. She loves all things space and astronomy related and always wants to learn more. She has a bachelor's degree in English and astrophysics from Agnes Scott College and served as an intern at Sky Telescope magazine. She loves to speak to groups on astronomy-related subjects. She lives with her husband in Atlanta, Georgia. Follow her on Blue Sky at astrowriter.social.bluesky.